Assalamualaikum warahmatullahi wabarakatuh. Today I will present about calculus 1 MAT183. Okay, firstly, this is our group members. First, we have Muhammad Azri bin Yusuf, that is me. Also have Farah Ismi bin Haris Patila, Muhammad Faiz bin Basri, and lastly, Syaratul Akidah bin Abdul Rashid. Okay, so our topic, we have application of differentiation analysis of function. For the introduction, we have this part in our slide. Firstly, related rates. Second, analysis of function 1. Third, analysis of function 2. Fourth, maximum and minimum problem. And lastly, Rolle's theorem and mean value theorem.
Okay, so for our group, we are using analysis of function 2. In analysis of function 2, we have relative maxima and minima, first and second derivative test, graph of rational function, critical point, and graph of polynomial function. So for our problem, we are using graph of rational function. So this is our problem segment. Given a function fx equal 4x minus 1 over x minus 2, question A, x-intercept and y-intercept, B, vertical and horizontal asymptote, C, f prime x and f double prime x, D, the intervals where fx is concave up and concave down, E, the extremum points and inflection point, F, sketch the graph of fx using the above information.
So first, I will start with the first question. Given the function fx equal to 4x minus 1 over x minus 2. A. Find the x-intercept and y-intercept. To find the x-intercept, fx must equal to 0. So use the function given fx minus 1 over x minus 2 equal to 0, and then use the numerator, which is 4x minus 1 equal to 0, and then 4x equal to 1, x equal to 1 over 4. Next, to find the y-intercept, you must substitute the x equal to 0. So the equation will be f0 equal to 4 multiplied by 0 minus 1 over 0 minus 2. So the answer will be y minus 1 over y negative 1 over negative 2. So the intercept for x will be 1 over 4, 0, y, 0, 1 over 2. Next, for question B, find the vertical and horizontal asymptotes of fx. For the vertical, we must use the denominator of the function. So x minus 2 equal to 0, x equal to 2. Horizontal, limit fx, x approach to infinity, 4x minus 1 over x minus 2. And then 4x minus 1 will divide by the highest degree of the denominator, which is x. So 4x over x minus 1 over x over x minus 2 over x. And then you can just cancel the x, so it will be 4 minus 1 over x x over x is equal to 1 minus 2 over x. And then x is approaching to infinity. So you must substitute the x into infinity. So it will be 4 minus 1 over infinity over 1 minus 2 over infinity. Any number that divide by infinity is equal to 0. So the final answer will be 4 minus 0 over 1 minus 0. So y is equal to 4.
For question C, we must know the u and the v. So for the u is 4x minus 1, and for the v is x minus 2. So for the to find the f prime x, we have to use this formula, which is vu prime minus uv prime divided by v squared. So for the v, we have x minus 2. For the v prime, it will be 1. And for the u, equal to 4x minus 1, and u prime is equal to 4. So f prime x will equal to x minus 2 multiplied by 4 minus 4x minus 1 multiplied by 1 divided by x minus 2 squared. So the answer will get 4x minus 8 minus 4x plus 1 divided by x minus 2 squared. So it will equal to negative 7 divided by negative 7 over x minus 2 squared. And the final answer will get negative 7 over x minus 2 squared. So it will equal to negative 7 multiplied by x minus 2 negative power of negative 2. So to find the f double prime x, it will equal to 14 multiplied by x minus 2 the power of negative 3. So it will equal to 14 over x minus 2 the power of 3.
So for question D, we must find the intervals of the function for concave up and concave down. So the first step is to let x x minus 2 bracket close cube to be equal to 0. The value of x equals to 0. The next step is to draw the table, which includes the interval, the test value, and the sign of f double prime x. So based on the number line, we know that it starts from negative infinity to 2. So we choose the number 0 and sub in 0 into the f double prime x function. So we will get the negative sign. The next one is for from 2 to 2 to infinity, we pick the test value number 3, then sub in 3 into the f double prime x, and hence we get the positive sign. From this, we can conclude that the concave up is from the concave up is 2 to infinity, and the concave down is from negative infinity to 2. Let's find the inflection point and the extreme point. So to find the inflection point, we must let x equals to 2 and sub in 2 into the original question. So in this case, 4 times 2 minus 1 over 2 minus 2, we get 7 over 0, which will become undefined. In this case, the inflection point does not exist. For the extreme point, let negative 7 over in brackets x minus 2 square be equal to 0. Hence, the extreme point does not exist due to there's no such value. For the final question, we must draw the graph. We must sketch the graph which on the question. So sketch the y intercept and x intercept, and also the vertical and horizontal asymptote. That's all.
Okay, for the conclusion, the graph show that it is a rational function graph, and the graph has concave up and concave down. Okay, that's all from our group. Thank you so much.